Powered Parachute Handbook 10.1 Airport Traffic Patterns. Let's delve into the intricacies of airport traffic patterns and operations, a crucial aspect governed by 14 CFR Part 91 for powered parachutes. Compliance with these regulations is paramount as it mandates that powered parachutes steer clear of the flow of fixed-wing aircraft, ensuring safe and efficient operations in shared airspace. For a comprehensive understanding of airport operations, pilots should consult both the Aeronautical Information Manual, AIM, and the Pilot's Handbook of Aeronautical Knowledge, which serve as invaluable resources providing detailed insights. The commencement and culmination of every flight occur within the confines of an airport, defined as an area designated for aircraft landings and takeoffs. Given this pivotal role, it becomes imperative for pilots to acquaint themselves with the traffic rules, procedures, and patterns prevalent at various airports. A critical consideration emerges as we acknowledge that a significant portion of aviation accidents transpires within the proximity of airports. This area witnesses heightened congestion, demanding utmost vigilance from pilots who find themselves intricately engaged in the operational ballet of takeoffs and landings. The fundamental tenet of see and avoid takes center stage in ensuring safe operations, especially at non-tower-controlled airports and flying fields. Utilizing advisories on the Common Traffic Advisory Frequency, CTAF, becomes indispensable, allowing pilots to communicate their position and intentions to other aircraft in the vicinity. To bolster safety around airports, specific traffic patterns and control procedures have been instituted. These traffic patterns delineate designated routes for takeoffs, departures, arrivals, and landings, contingent upon factors such as the active runway, wind conditions, obstacles, and other considerations. The intricacies of these traffic patterns may vary based on the type of aircraft and its airspeed. Notably, slower aircraft, such as powered parachutes, necessitate careful consideration, aligning with the overarching principle that slow and fast aircraft should maintain a safe distance. This principle is equally applicable to helicopters. A crucial point of consideration is the choice of landing site, a decision influenced by factors such as surface conditions, obstacles, and the wind. The optimal operating surface for powered parachutes is grass, minimizing wear and tear on the canopy. However, it's crucial to acknowledge that off-runway operations may disrupt normal airport activities and pose safety concerns, prompting pilots to meticulously evaluate the chosen area for potential hazards. Moreover, a distinct traffic pattern may be established for off-runway operating areas, emphasizing the need for pilots to be aware of their position relative to other aircraft and to avoid the flow of fixed-wing aircraft, extending the principle to helicopters as well. In the context of airport runways, consideration should be given to potential crosswinds. The decision to use the runway necessitates evaluating wind conditions, ensuring alignment with the powered parachute's flying skills, and adhering to canopy limitations. The specifics of powered parachute traffic patterns may align with standard patterns or adopt variations, such as a tight pattern or inside pattern, enhancing separation from faster aircraft. A thorough review of the Airport Facilities Directory, AFD, becomes essential to understand the unique procedures at each airport. Airports exhibit a spectrum of complexity, ranging from small private grass strips to major terminals with multiple paved runways and taxiways. Regardless of the airport's scale, adherence to rules and operating procedures is non-negotiable, guided not just by logic but also by courtesy. These measures aim to facilitate the smooth flow of air traffic, ensuring maximum safety and efficiency. Control towers and radar facilities play a pivotal role in managing air traffic flow, particularly in busy terminal areas. Pilots must be well versed in communication requirements at the airports they operate in, facilitating seamless interactions with these facilities. The significance of airport lighting, markings, and signs cannot be overstated. These elements serve as vital indicators, alerting pilots to abnormal conditions, hazards, and providing essential guidance for safe airport operations. As we delve into the intricacies of navigating standard airport traffic patterns for powered parachutes, a topic that holds paramount importance under the regulatory framework of 14 CFR Part 91, emphasizing the imperative to steer clear of fixed-wing aircraft flows. This directive significantly influences our considerations when deciding whether adherence to a standard airport traffic pattern aligns with our operational requirements. To initiate our discourse, it is pivotal to recognize that airports craft specific traffic patterns tailored to their local conditions. These patterns dictate the directional flow, placement, and altitude considerations, as well as procedures for entering and exiting the pattern. In the absence of visual markings instructing otherwise, turns within the pattern conventionally occur to the left. It is noteworthy that airports may delineate distinct patterns and altitudes for light sport aircraft, LSA, operations, necessitating consultation with the airport manager and reference to the Airport Facility Directory, AFD, for pertinent details. In the realm of operational control towers, the dissemination of radio clearances for approach or departure, coupled with vital traffic pattern information, becomes streamlined. However, at non-towered airports, the onus rests upon us to discern the traffic pattern direction, adhere to established rules, and exercise courtesy towards fellow aviators. Leveraging the Common Traffic Advisory Frequency, CTAF, and attentiveness to the Automatic Terminal Information Service, ATIS, enhances our situational awareness. While an exhaustive understanding of traffic patterns across all airports may be impractical, a foundational grasp of the basic rectangular pattern serves as a versatile toolkit for approaching and departing from most airports. A perusal of the Airport Facility Directory equips us with valuable insights into airport-specific traffic patterns. In scenarios featuring operational control towers, deviations from the standard rectangular pattern may be mandated to optimize traffic flow. Larger aircraft, often executing wider patterns, introduce variables necessitating adaptive measures for seamless traffic coordination. For powered parachutes, a critical adjustment involves acknowledging that our pattern altitude should be half that of general aviation, GA, patterns. This nuanced adaptation is pivotal to avoid conflicts with faster aircraft, considering that even after decelerating to traffic pattern speed, airplanes maintain a speed 2 to 3 times that of powered parachutes. Initiating entry into the traffic pattern at non-towered airports entails vigilant observation of existing traffic and adherence to established patterns. Ground indicators and wind indicators become instrumental in determining runway and traffic pattern direction. A judicious 45-degree angle entry to the downwind leg is recommended for landing approaches, ensuring proper altitude and steering clear of existing traffic until established on the entry leg. The downwind leg, a parallel course to the landing runway but in the opposite direction, necessitates completion of pre-landing checks. Sustaining pattern altitude until abeam the approach end of the runway facilitates a seamless descent. A medium bank turn onto the base leg follows, serving as the transitional segment between the downwind and final approach legs. The base leg, contingent upon wind conditions, provides sufficient distance for a gradual descent. Our ground track should align with the extended centerline of the landing runway. Ensuring safety and averting collisions with other aircraft on final approach is paramount before turning onto the final approach leg. The final approach leg, spanning the base to final turn to touchdown, demands acute judgment and precise control over airspeed and descent angle. Regulatory guidelines affirm the right-of-way for aircraft on final approach, with lower altitude aircraft holding precedence. Caution and refraining from taking advantage of right-of-way rules are urged to prevent encroachment on the path of other landing aircraft. The upwind leg, mirroring the runway's direction, entails a 90-degree turn onto the crosswind leg. This segment acts as a transitional phase for the final approach, go-around initiation, and establishing climb attitude post-takeoff. Departure from the traffic pattern involves a straight climb on the upwind leg or a 45-degree exit turn, ensuring a safe altitude is attained to clear ground obstructions. In situations involving parallel operations, with airplanes on hard surfaces and powered parachutes on grass, strict adherence to established patterns without traversing active runways is imperative. Furthermore, refraining from initiating turns until certainty prevails about avoiding obstruction to other aircraft is prudent. The crosswind leg, perpendicular to the extended centerline of the takeoff runway, entails a 90-degree turn from the upwind leg. Subtle adjustments into the wind may be necessitated to maintain a ground track perpendicular to the runway's centerline extension. In summary, mastering the intricacies of standard airport traffic patterns for powered parachutes demands a meticulous understanding of regulations, pattern altitudes, entry and exit procedures, and the ability to adapt to variations for efficient and safe operations. These considerations underscore the significance of a comprehensive approach to navigating the skies within the bounds of regulatory directives.